Today we're going to learn about rational functions. This is an example of what a rational function can look like. So guys, today we're going to learn how to find x-intercepts, vertical asymptotes, holes, horizontal asymptotes, and y-intercepts. This is your first example. Go ahead and factor that. Ready to go. Factor it. Factor the numerator and then factor the denominator. All right, so guys, this is our first rational function. You're always going to start off these problems by factoring. So if you factor the numerator, what were two numbers that multiply to -3 but add to -2?
-3 and 1.
Perfect, -3 and 1. Okay, what about two numbers that multiply to 2 and add to 3?
2, x plus 1, x plus 2.
Perfect. Okay, so guys, this is your factored form. Now let's go about trying to find the x-intercepts, the vertical asymptotes, and the holes. Okay, now, do you guys see what the numerator and the denominator both have in common so that we can cancel it out? Exactly. The x plus 1, they both have that in common, so we'll cancel that out.
Okay.
All right, let's start. X-intercepts, you set the numerator of the simplified function, so this is the simplified part because we canceled that out. You set it equal to 0 and solve. So your numerator is x minus 3. Set it equal to 0, you solve it and get 3. So your x-intercept is at 3, 0. To find the vertical asymptote, you set the denominator, so right here, x plus 2, equal to 0 and you solve. So you get x equals -2. So guys, notice, do not write your x-intercept as x equals 3 because you might be confused and might get confused with the vertical asymptote. So write your x-intercept as a point, not an equation, okay? Your asymptotes are written as equations. Next, holes. If there was a common factor, so we did have a common factor, we canceled out the x plus 1s. So if you have a common factor, you set it equal to 0 and you're going to solve. So what I canceled out was x plus 1. Set it equal to 0 and solve. You get x is -1. That is the x value of the whole. To find the y value of the whole, so the simplified problem, you have x minus 3 over x plus 2. You are going to plug in -1 in for the x's. This will give you the y value. So -1 minus 3, that's -4. -1 plus 2 is 1. So you get -4. That is the y value of your whole.
Are you always going to have things that you cross out?
No, not always. Let's try this one. So your first step is to always factor. So let's look at the numerator. I have 3x squared minus 12. What can these both be divided by? 3. So 3 is on the outside and we simplify. Do you guys know what this is called? A difference of squares. So how can I write the numerator?
X plus 2, x plus 2.
Yep. Y'all got it. So that is my numerator factored. We had to remember that this is a difference of squares. You can square root this and square root this. So you get x minus 2 and then do the opposite, x plus 2. Okay, now let's factor the denominator. I need two numbers that multiply to -8 but add to 2.
-2 is 4.
Yes. All right, so I factored everything. Let's go ahead and simplify it real quick. This factor cancels with this factor, so that means I will have a whole. If anything cancels out, that means you will have a whole, okay? All right, so let's find the x-intercepts. To find the x-intercept, you set the numerator equal to 0 and solve. So my numerator is 3 times x minus 2. Oh, x plus 2. This is my numerator, set it equal to 0, and we'll solve. This 3 doesn't even matter, because when you divide by 3, you just get x plus 2 equals 0. So it's just -2. Make sure you write it as a point. Okay, now let's find the vertical asymptote. You set the denominator equal to 0. So my denominator is x plus 4. When you solve it, you get x is negative 4. So that is your vertical asymptote. We do have a hole because we canceled something out. So whatever you canceled out, you set it equal to 0 and you solve. So you get 2. So that is the x value of the hole. We're going to plug 2 into the problem to find the y value. So erase this x and this x, and I'll plug in a 2. So I get 3 times 2 plus 2 is 4. Then I have 2 plus 4, that's 6. So I get 12 over 6, which is just 2. So this is the location of my hole. Yes.
What does the hole mean?
The hole, that is where, so if you look at this is a value that you cannot equal.
Why?
It'll just be a blank on your graph.
Because it's undefined or something?
Yes, it's undefined where the hole is. So it's undefined on your asymptote and at your hole.
Why?
Why? Because if you, well, one, you have your asymptotes, and then your holes. If you go back to this problem, if you go back here, if you go back to the original problem where we factored, if you plug in an x equals -1 right here, you get 0 in the denominator. That's why there's a hole. So, very good question. If you go back to the original problem before you simplified it, if you plug in a -1 right here, -1 plus 1 is 0, and 0 times whatever that is 0. You can't have 0 in the denominator, so it results in a hole. Okay? Good question. Let's try one more example, and then I'm going to let you guys practice this on your own. Your first step, guys, is to always factor. So the numerator is already good, but let's look at that denominator. Give me two numbers that multiply to 15 and add to 8. Yep, 5 and 3. So those cancel. You're just left with 1 over x plus 5. Okay, let's find the x-intercepts. You set the numerator equal to 0 and solve. Your numerator is 1. Does that make sense?
No.
Okay, so that means there is none. You have no x-intercepts. Next, let's find the vertical asymptote. You set the denominator equal to 0. And you solve, so you get x is -5. Do we have holes? Yes? How do you know we have a hole? Yep, we have common factors that we canceled out. So whatever you canceled out, you set it equal to 0 and you solve. So you get x is -3. That's the x value of the hole. And if you plug it in a -3, you get 1 over 2. So that is the y value of your hole. Okay, I'm gonna help you start the next one. I'm only doing these because y'all are encountering some new things on each example. For this one you encountered, oh, it's a possibility that you won't have an x-intercept, okay? So let's look at this one here. Let's look at the numerator. What can these both be divided by?
6x.
Yes,
6x.
a 6x. So that goes on the outside. 6's cancel, you're left with x squared. Anything divided by itself is just 1. And you can always check. If you can go back, that means you did it correctly. Okay?
They're squares, right?
Yes. What do we call that?
Difference of squares.
Difference of squares. So how am I going to write the numerator?
6.
X plus 1, x minus 1.
Yep. X plus 1, x minus 1. So that's your numerator factored. Now, the denominator over here, let's factor it. What can both of these be divided by?
X.
X. So x will go on the outside and we're going to simplify. This will be x minus 2. So your denominator is x times x minus 2. Do you see anything in common?
No.
Really? Look closer.
X.
The 6x and the x.
Oh.
The x's can cancel. So we will have a whole. Okay. So x-intercepts. You set the numerator equal to 0 and solve. So in the numerator, I have 6, which won't really matter, because all these are being multiplied. So the opposite is to divide by 6, and it just goes away. That canceled out, and 0 divided by 6 is just 0. It didn't matter.
Yep.
Okay, set this equal to 0, what will you get?
-1.
So you got -1 as one of your x-intercepts. Set this equal to 0, what will you get? Yep, so you have 2 x-intercepts. To find the vertical asymptote, you set the denominator equal to 0. So this is your denominator. Set it equal to 0, solve, you'll get 2. Finally, the whole. We canceled out an x. So whatever you canceled out, you set it equal to 0. Okay, so that's the x value of the whole. And we'll plug that into here and see what y value we get. So I'm going to erase these x's and replace them with zeros.
They just cancel.
So we
it's
get,
just 0.
hold on, 0 plus 1 is 1, 0 minus 1 is a -1, and 0 minus 2 is a -2. So you get -6 in the numerator and -2 in the denominator. 3. So that is the location of your whole. Now we're going to talk about horizontal asymptotes. So P stands for a polynomial and Q stands for a polynomial, okay? Now, if the degree of the numerator is greater than the degree of the denominator, that means you will not have a horizontal asymptote. There will be none. So an example of this, let's say you have x squared plus 2x minus 3 in the numerator and then x plus 5 in the denominator. This the leading degree is larger than this leading degree. So whenever the degree is bigger on the top, you are not going to have a horizontal asymptote. If it's big on top, your answer is none. So if you have a bot, your answer is none. Big on top, okay? All right, now let's do a different example. Let's say the degree in the top, the degree on the top, P, is less than the degree of the bottom. So this time it's big on bottom. The answer will be 0. I like to say bobo. Okay, so it's y equals 0. And here's an example. You can just switch it. The x plus 5 is in the numerator and the x squared is in the denominator. You see the exponent? It's bigger on the bottom. The degree is bigger on the bottom. If it's big on the bottom, your answer is 0. Okay, next example. If your degrees are the same, they're equal. Your exponents are the same. So let me give you an example. Let's say I have x squared plus 2x minus 3, and then an x squared plus 4x plus, 6. You see your exponents are the same, the degrees are the same. What you're going to do is, your answer will be y equals, and then you divide the coefficients. So here your coefficient is 1, here your coefficient is 1. So the answer for this example is y equals 1. That's where your horizontal asymptote would be. Let me give you another example. Let's say these degrees were 3 and 3. Your degrees are the same. Let's say this was 3 over 6. You divide the coefficients. So 3 over 6 simplifies to 1/2. So your horizontal asymptote would be at 1/2. Okay? Yes. Yes, I have an acronym. So, exponents are the same. Divide coefficients. We call this EATS, EATS, DC. Exponents are the same. So look at my exponents. They're the same. What did we do? We divided the coefficients to get 1/2. Okay? If it's big on the bottom, like this example, you have a 2 on the bottom and a 1 on the top. So your answer was 0. Big on bottom, 0. Bobo. Whatever acronym you want to use. Okay? You can come up with your own. For this example, the exponents are the same. What is it?
Y is equal to 1.
Because what did you do?
Divided the
Divide
coefficients.
Divided the coefficients. 1 divided by 1 is 1. For this one, it's big on the bottom. What is it?
0.
0. Bobo.
Big on.
Okay, what's this one? None, because it's big on top. These are what?
These are the same.
They're the same, so what's the answer?
2.
2, because 8 divided by 4 is 2. Nice. Okay, this one's big on top. What is it?
None.
None. This one's big on the bottom. What is it?
0.
0.
This one's big on top.
None.
None.
Nice. And these are the same. What is it?
Negative 1/3.
Perfect, because you divided it and you simplified your fractions. You always simplify your fractions. Okay. Now we're going to put everything together. Ready? We're going to put everything together. Your first step is to always factor. I'm going to divide both of these by 2. So 2 is on the outside. I'm left with x minus 3. Right? Because 2 times x is 2x. 2 times 3, you get the 6. So that's the numerator factor. Your denominator is x minus 1. Does anything cancel out?
No.
So what does that mean?
No.
So for wholes, put none. Nothing canceled out. X-intercepts, how do we find them?
Set the top equal 0.
Exactly. The numerator is 2 times x minus 3. Set it equal to 0 and we'll solve. So if you divide by 2, you get x minus 3 is 0 and you'll get x is 3. Please write it as a point. It's not a vertical asymptote. Okay. Vertical asymptote, how do you find it?
Set the bottom equal to 0.
Exactly, the bottom equal to 0. So x minus 1 equals 0. X equals 1. Horizontal asymptote, look at the original problem. Big on bottom, top were the same. Same. They both just have an x.
So it's 2. 1 equals 2.
Yep. 2 over 1 is just 2. Okay. Finally, the y-intercepts. We did this last class. How do you find y-intercepts?
You look at the transform.
Yes, you plug in zeros. So guys, look. I'm going to erase these x's. Plug in zeros. For y-intercepts, you plug in zeros. So I get 2 times 0 minus 3 is negative 3. 0 minus 1 is negative 1. So you get negative 6 divided by negative 1, or what is it?
Just
Just 6. A negative over a negative is positive. So your y-intercept is at 0, 6. Let's go ahead and graph everything that we found. Your x-intercept is at 3, 0. That is right here. Your y-intercept is at 0, 6. Your vertical asymptote is at 1. Your horizontal asymptote is at y equals 2. So draw a line through the y-axis at 2. Okay, so this is how you're going to draw your graph. Get close to the asymptote, go through your point. Get close to the other asymptote. Close to this asymptote, go through your point. Get close to that asymptote. That's your graph. The domain, it is always going to be in this format. For the domain, you need to look at this vertical asymptote. X is equal to 1, so there'll be 1s here. For horizontal asymptote, you look at y equals 2. That's what goes for the range. For the range, you can be on the bottom part, So you can be below the 2, so that's negative infinity to 2, or you could be above the 2, 2 to infinity. Okay? So that's how you do your domain and range. Our next example. Guys, go ahead and factor it. What do you guys notice?
There's the big is on top, so there's no vertical asymptote.
That's true. Okay, so you said that it's big on top, so there's no horizontal asymptote and difference of squares. So if you factor it, what will we have?
X minus 1.
Perfect. It doesn't matter if you said x plus 1 or x minus 1 first, as long as you have both of them. And those cancel, yay!
Okay.
You're just left with x plus 1. Okay, so let's find the x-intercepts. For x-intercepts, you set the numerator equal to 0 and solve. So if you want to make your numerator, you can do that. Or you could just equal the x plus 1 to 0 and solve it. You get negative 1. Please write it as a point. How do you find the y-intercepts?
Plug in zeros.
Plug in zeros. So plug a 0 in here. What do you get?
1.
1. So that's 0, 1. Let's go ahead and graph that.
Wouldn't it be 0 negative 1? Because you're setting it equal to 0?
No, we're not setting it equal to 0. We're plugging in 0. You plug a 0 in here.
Okay. And then you would set that equal to 0? Or
No.
Setting it equal.
This is y equals this. Y equals this. So 0 plus 1 over 1, y is equal to 1. 1.
Okay.
So your y-intercept is at 0, 1. Your x-intercept is at negative 1, 0. All right, let's keep moving. Vertical asymptote, you set the denominator equal to 0. Well, the denominator is 1. If you equal it to 0, that makes no sense. 1 does not equal 0. So there is no there's no vertical asymptote. Did we cancel anything out?
Yes.
Yes, so we do have a hole. Okay, so my hole. We have x minus 1. Set it equal to 0 and solve. You get 1 for the x value. Plug 1 into here. 1 plus 1, you get 2. Go ahead and plot your hole. So 1, 2 is right there. So guys, let me point something out to you. This graph that we have, this equation, this is just your basic mx plus b. 1 is your y-intercept. That's why you have a 1 right there. Your slope is 1. That's why you go up 1 over 1 between the points. So this is just a straight line.
My type of algebra.
Don't go through the hole. You cannot be on the hole. So your domain on the left, it's pointing to the left, negative infinity. To the hole, the x value is 1. Then continue on the other side of the hole, 1 to infinity. The very bottom is pointing to negative infinity, and it goes up to this y value, that's 2. And then it continues on the other side of 2 to infinity. Yes?
The bracket means would be like greater than or equal to.
Right. That's why we have parentheses. Because this is like the less than symbol. Not the less than or equal to. Less than or equal to is a bracket. We cannot be equal to that whole. Good question.